Alright, getting started now on the last topic of Module 1. Here we're looking at the absolute value equations and absolute value inequalities. And we're going to go over the technique used to get the right answer. Well, as background, the absolute value of anything is always its positive value. So if you have a negative value in here, when we take the absolute value of it, it's its positive value. Now, the exception to this, of course, is when it's 0. 0 is an unsigned number, so that could be a little tricky. All right, well, let's get started. Now, as we do this, there is a certain protocol to follow as we do it. And when you have the absolute value of something equals a positive number, again, this is a true statement, we would write it, take away the absolute signs, and say x equals 2. And then you write or x could have equaled a negative 2. That is the opposite sign of this. Now here's where it gets a little tricky. Here we're saying the absolute value of something is a negative 10. Well, by definition, this cannot be true. So for this, there is no solution. Now, as we just said, the absolute value of 0 is 0. And it's unsigned. Now we'll move it up and go on to do some others. Again, the protocol for this is you take away the absolute signs. X minus 5 equals 2, or x minus 5 equals a negative 2, opposite sign. And you just solve this. So here x equals transpose 7, or x equals transpose on this side, it becomes a positive, and that would give you a positive 3. So these are the two values. This could have been a negative under here, and we could have it as a positive as well. All right, this one, 2x minus 3 equals 7, or 2x minus 3 equals a negative 7. So in solving this, this becomes 2x equals transpose 10, x equals 5. When we transpose this, it becomes a positive 3. So here we get 2x equals a negative 4. Divide both sides by 2, x equals negative 2. Again, this is tricky because they're saying absolute value equals a negative. That can't be. So this is a empty set. There's no solution. All right. Look down here, I see we do have one after all. So let's do this one. This would be 3 absolute value x minus 2 minus 3 equals 9, or, and what we could do here before we did the or, we would actually simplify this. So let's do so. We're going to bring this over This becomes a positive 3, so this is 12. Now we're going to divide both sides by 3. So we get x minus 2, absolute value is equal to 4. Now we do the OR. So it would be x minus 2 equals 4, or x minus 2 equals a negative 4. So here x equals 6. Here x equals a negative 2. So far, not too bad. All right, let's go on. Now, for these, we have inequalities, and they also want us to graph our solution set. So, a slight little difference here. We have the absolute value of x is greater than 4. Just remove the inequalities, the absolute sign, and just write it out. That's 1. Then we have or the absolute value of x, which will be x. But now we have to reverse the direction of our inequality sign from greater than to less than negative 4. And let's graph this. And we have here a negative 4. And we have here a positive 4. So when we graph this, x is greater than 4. It's a parenthesis going in this direction. And x is less than a negative 4 would be a parenthesis going in this direction. Now you might say, well, what do we have here? Well, as background, anytime you have the absolute value of something is greater, we have in a sense a union, which we call a disjunction. That these are disjoined, and we had some like this before. And in interval notation, although they're not asking for it, it would be from, again, negative infinity, a little review, up to negative 4, union 4, positive infinity. So anytime you have absolute value is greater, you're going to have a disjunction, and that's going to be an OR. Now notice our inequality sign here is less than. Anytime you have an absolute value that's less than, this is actually an and that's an intersection. So let's do this one. So x is less than 5, and x is greater than a negative 5. Again, we have to reverse the inequality sign and opposite sign. So when we graph this, it'll be a negative 5 and a 5. But from the negative 5, x is greater, so we go this way. And for this one, x is less than 5, we go this way, and we fill in between. So this is what we call a conjunction. And take these notes down. because they will be asking for this. Let me put a nice dot there. Now, looking at this, what are you going to have here? A conjunction or a disjunction? Just looking at the inequality sign. It's less than, so you're going to have an intersection, and this will be an and. And we'll set it up for you. It's 2x plus 6 is less than or equal to 12, and 2x plus 6, have to reverse the signs, is greater than or equal to negative 12. So take a moment and see what you get. And we're going to transpose here. This gives us a 6. And we have x is less than or equal to 3. And transpose there, we get 2, put it up here, 2x is greater than or equal to negative 18. 2 are just plain x now, is greater than or equal to negative 9. So there's our negative 9, there's our 3, and they are brackets now. And that is a conjunction. So we've solved it, we've given the graph. Here we should put it in interval notation just for practice. Negative 5, comma 5. And here bracket negative 9, comma 3, bracket. So let's pause and reflect. If you have any questions, this is the time to ask. Now, in the instructions, they're not asking us to put it in set builder notation, but I see as one of the answers below they do. So let's put this, or any of these, in set builder notation. Again, you would use a brace, and you would say x. X is such that x, and you would start with a negative 9, and then here is less than or equal, what's in the middle is x, and is less than or equal to 3. So that's set builder notation. And for this one, it would be similar. Brace, x is such, and then negative 5 is less than x is less than 5. Now, for a disjunction like this, where it's an or, your set builder notation would be, you would write this and this. Okay, but again, I don't think they're asking us for this. Any questions? Now, keep in mind, as you work in your homework log, anytime you have a particular question from practice or quiz me, and then later even a test, you can bring that in the lab. That's what labs are for, to go over those you have trouble with. And again, I have time here as well to help you with some. Okay, so again, understanding this. So this is just in function notation, and basically we can set it up this way. Absolute value of 4 let's do that better here. There we go. Absolute value of 4x minus 3 is greater than 2. Now, since the inequality sign is greater, will this be a union or an intersection? That is, a disjunction or a conjunction? Well, we said if it's greater than, it's a union, which will be a disjunction. And we set it up by just taking away the inequality signs. I mean the absolute signs. And then we're going to write or, because it's a union, a disjunction. And then we write it again. 4x minus 3, changing the direction of our inequality sign, and then the opposite sign of our 2, which is a negative 2. Okay, we transpose this. This becomes a 5. And we get x is greater than 5/4. And here we transpose the negative 3, and that becomes a positive 3, so this is a 1. And we get 4x that is less than 1. X is less than 1/4. So on our number line, we have two values, the 1/4 right there, and the 5/4, which is right there. Now we know this is a disjunction, and our symbol will be a parenthesis going this way and parenthesis going that way. And that is our final answer. Now, in interval notation, this is from negative infinity, comma, up to 1/4, parenthesis, union symbol, parenthesis, 5/4, comes right from the graph, comma, infinity. Infinity is always with a parenthesis. Now, if on your test, when you do take a test, and you're putting this in, sometimes students forget to put the negative sign here for negative infinity. I would give you full credit for this, because where is this coming from? This is negative infinity on this side. So, they're going to count it all wrong, but I'm going to be able to override the program by giving you credit for this. Now keep in mind, showing your work is super important throughout the course and preparing you for your exit exam. Now it's important to stay up to date. At the end of 4 weeks, you should be taking your Module 1 test if you haven't already. Now later down the line, you can take it again and get a higher grade. But you need at least a 70% to be able to take Module 2's test after you get the required number of mastery points. So, we're going to have some extra exercises now as part of our classwork. But again, if you have any questions, before you be sure to ask them.